Hello everyone, I am Swati Anandram and I have conducted the paper review on supervised machine learning. So data is growing in every field and every organization. The organizations such as economics, health, education, they all obtain helpful information from these big cumulative data sets. It is crucial to utilize the enormous amount of data that is present to solve the problems that can benefit the organization. Let us first talk about what is artificial intelligence. Artificial intelligence aims at mimicking human intelligence. It has gained a lot of popularity in various fields such as image recognition, speech analysis, game planning, forecasting, self-driving cars, and many more. AI has many techniques that are used extensively, such as knowledge representation and reasoning, pattern recognition, NLP, that is natural language processing, machine learning, deep learning. So these are a few. So the next question that arises is, how is machine learning related to artificial intelligence? Machine learning is basically a subfield of artificial intelligence that aims towards answering many questions that are related to data. As the research on artificial intelligence is growing, a canonical AI architecture has been defined that ensures end-to-end ecosystem of AI. Let us talk about the steps involved in the AI process. The first is data collection. It involves a collection of data from different sources and different formats. Data conditioning. It involves transforming the raw data into important information through data curation, standardization, management, and data labeling. Data learning. It involves incorporating all the machine learning techniques to transform the obtained information into knowledge. Human machine training involves transforming the knowledge that is obtained in the previous step into insights. This diagram shows the artificial intelligence subfields. These are the major subfields: deep learning, statistics, data mining, machine learning, and pattern recognition. These are the subdomains of machine learning. First is supervised learning. Supervised learning, it needs the training data that is labeled with the inputs and the known outputs. Whereas for unsupervised classification, it does not need labeled data. So we'll come to that again. Talking about supervised learning, the significant goals of supervised learning is solving the problems that are related to regression and classification. Regression models basically aim at predicting a value of a continuous variable. So what a continuous variable is, that it's a variable that can take any value between its minimum and the maximum value. For example, a particular regression problem can have the output variable as a real value such as dollars or weights that can be predicted. The another goal is classification model. So they aim at classifying a label of a class of an unseen data. So for example, there can be a classification problem in which the output variable is a category such as red or blue, disease, no disease, spam or not spam. So talking about unsupervised learning, it does not need labeled data and the inputs need not necessarily have a known output. It aims at identifying the clusters, as you can see in the diagram, without prior knowledge of class labels for input data while training. Unsupervised learning comes up with the clusters based on most frequent pattern at the end of each training step. The input data is assigned to a particular cluster during the testing phase. Unsupervised learning is mainly used in clustering and dimensionality reduction. Dimensionality reduction, it is a technique that aims to transform the dataset dimensions from a higher dimension to a lower dimension without affecting the data dispersion shape. Next comes the reinforcement learning. It learns through reward signals obtained while interacting with learning environment rather than the labels. So reinforcement learning involves interaction with the environment basically, as you can see in the diagram. This technique defines the model which changes the behavior in its environment based on the actions, on specific actions. The rewarding approach means that you have chosen an optimal action, and the learning environment keeps rewarding each action taken with a specific score. So it assigns that score, and the optimal transition is based on the rewards that are awarded. This diagram shows the major domains of machine learning techniques that are healthcare, forecasting, automating tasks, and security. Machine learning techniques have also gained popularity in big data analytics, natural language processing, fraud detection, and Internet of Things. So, as we can see in the diagram, it, it is properly mentioned that supervised learning takes classification or regression problems, unsupervised takes clustering and dimensionality reduction, and for reinforcement learning, it's decision making, and all the different applications of the various subdomains of machine learning is given in this slide. So it is very crucial to evaluate a particular model's behavior and its performance. So let us talk about generalization. If you have a strong generalization, it means that the model predicts better with new and unseen data. And generalization gives a degree of performance of model on the new data. Next comes the regularization. Regularization is balancing between bias and variance, which will result in the machine learning model to give better results while training and testing. So talking about bias and variance, bias is the difference between the average prediction that our model is giving and the correct value which we are trying to predict. Variance is basically a variability of model prediction for a given data point or a value which tells us the spread of our data. Next comes the bias and variance trade-off. So when a model it behaves pretty well while testing, it has a variance, right? And it performs poorly when generalization error is pretty high, and this results in overfitting. When a model performs poorly and the bias is very high in the training step, it is called as underfitting. And regularization is used to find the balance between this high bias and high variance while maintaining the model complexity. These are the two error evaluation metrics in regression model. So root mean square error and quantile error are used basically to evaluate the regression model performance. So before we understand this, let's talk about R squared. It is basically a correlation metric that shows the strength by which two variables are related. Whenever the correlation is near +1, it means that it has a strong relation in a positive manner. And if it is nearing to -1, it means that it has a strong relation but in a opposite way. Similarly, if a correlation is nearing 0 or is equal to 0, then the variables show no correlation. So now let us talk about root mean square error. It is the square root of average squared distance between the actual and predicted values, as we can see in the formula. But RMSE has its drawbacks, that it fails to provide accurate result in case of data sets which has a lot of outliers. That is when we tend to use quantile error. So this overcomes the drawback of RMSE. And it takes the median value instead of the average value, as it was in the case of root mean square error. Let us talk about evaluation metrics in classification model. So accuracy is the metric showing the ratio of correct predictions in total to the number of records present in dataset. Accuracy is actually not a good metric to use in an imbalanced dataset. Next comes the confusion matrix. It calculates the number of occurrences of class labels for both true classification as well as false classification. Now let us look at what these terms mean, that is true positive, true negative, false positive and false negative. So basically, confusion matrix counts the occurrence of each class that will be positive and negative for each state. The count of positive and negative samples which are predicted correctly is called as true positive and true negative, and the count of positive and negative samples that are not predicted correctly are called as false positive and false negatives. There are many metrics that make use of these values, that is true positive, true negative, false positive and false negative. Those metrics are precision, recall and F1 score. Precision is the ratio of positive class correct predictions to all the positive class predictions. Recall is the ratio of positive class predictions to all positive cases only. And F1 score is the weighted average of precision and recall, or in other language, it actually overcomes the drawback of the accuracy matrix here, as it is the weighted average of precision and recall. It is majorly used in NLP, F1 score. This diagram shows the approach which is followed by supervised learning. So during the training phase of supervised learning, the training data consists of inputs that is paired with the labels, correct output labels. In the training phase, the algorithm searches for the patterns in data with correlation to the desired output. In testing phase, the supervised learning algorithm takes new inputs and determine how they will be classified. The model basically aims at predicting the correct label for these new data, as shown in the figure. These are the algorithms that are based on supervised learning. Let us talk a bit about these. The first one is gradient descent algorithm. It is a step-by-step optimization process that aims towards finding the minimum value for a particular function. Next comes the logistic regression. It is a mathematical model of supervised classification that is used for statistics to guess the probability based on inputs. It basically works well with binary data where the probability is 0 or 1. Next comes the k nearest neighbors. It is used for classifying new inputs based on similarity measures. K denotes the number of nearest neighbors that are considered for voting. Next is decision tree. It is a tree format used for classifying data elements in a tree structure. We can see the example of decision tree in the figure. We'll talk about it. So the nodes of a decision tree, they have levels, where the first level is called the root node and the second consists of all the branches, and at least one child has an intersection that produces the internal nodes. The classification algorithm branches to these child nodes till it reaches one of the leaf nodes. So this is the example that we can see for decision tree. It is built from a set of input data where the features used are outlook, and then we have sunny, overcast, humidity and windy. So the output will basically be as whether the person can play outside or he shouldn't play outside. Next comes the naive Bayes. It is used for classification that describes a probability of an event based on conditions associated with that event previously. And then comes the support vector machine. It produces accurate results with less computing power, and it relies on linear and non-linear separation data using a hyperplane, as we can see in the figure right next to it. Hyperplane to maximize the marginal distance between the two classes and minimize the errors. So the support vector machines are marginal distance between the hyperplane and the nearest instance. Next is artificial neural network. It is subset of ML algorithms that aim at simplifying and mimicking human brain and its processing of input signals and transformation to output signals. Thank you.